as much as you know what to code, you should also know how to code it in a clean and clear manner. Because if your code is not clean, your fellow developers will not be able to read and understand it. Okay, and then they will not be able to work on top of it. A dirty code is like a liability. So dirty code is a liability. Clean code is bliss. Okay. See, why clean coding is important? What are the main purposes of it? So if I ask you one simple question, yeah, easy to collaborate is one definite reason. But just think about it. Do you spend a lot of time in reading the code or do you spend a lot of time in writing the code? You spend a lot of time in reading the code, right? So if you join a company, if you join a new organization, you first read the code base, you read a repository, a GitHub repository, and then you understand which class does what, which component does what. And then you are able to understand that if somebody gives you a new feature or a bug to fix, where exactly to fix that bug. And quite interestingly, let's guess this number. If I ask you to guess the ratio of time spent in reading the code versus writing the code, what would that ratio be according to you? 10 is to 1, or it's 10 is to 1 or more than that for some people. Okay, so for every 1 hour of code that you write, that you actually write, just go on writing, you must have spent 10 hours in reading that code and understanding like what it is doing and all that. So just imagine if your code is very clean, it will be very readable. And if it is very readable, you will be able to ship new features faster. You will be able to, make changes fast. And speed matters in business. Any business, because at the end of the day, all the online businesses are dependent on code, right? Now, if the code is clean, the features will be shipped faster, so the business grows faster. And that's a very important thing. And even more important than that is that those people who are working professionals who have already had some experience of working at big organizations, they appreciate it because they have had a bare hand experience of seeing it, that how valuable the clean code is. The first benefit of clean code is to enhance readability, because readability is important. If there is a piece of code which takes you 1 week to understand, and on the other hand there is some piece of code which takes you maybe just 1 day to understand, you will be more productive, right? And it matters a lot. So what we are going to do is we will do one experiment. Okay, so I want you guys to do one quick and small activity over here. Okay, what that activity will be, I will share some code with you and I will only give you 1 minute, just 1 minute, okay, or at max 2 minutes to read that code. You'll have to read that code and you'll have to somehow understand what that code is trying to do. Okay, that is what you will have to do. Okay, so I'm just going to share my screen. Okay, just read this code. Okay, can you tell me what is this code doing? It's a tic-tac-toe game which is being played here. You can see there is a board. There are two players. The two players have been added to a queue. Why a queue? Because they are playing in turns. So first player is here, second player is here. The first player plays, goes back. And then the second player plays, goes back. So in turns, so that's the reason queue has been used. And now in this loop, we are fetching the current player from the queue who is at the front of the queue. We make that player make a move. Every move contains row and column. The row and column where that player wants to put something. And then that player can apply the move on that board. And now there is a method called as is game over. This method is game over. When is the game over in tic-tac-toe? You check the rows, you check the columns, and you check the diagonal. So if any row, column, or diagonal contains zeros or X, you say that the game is over. So this or that. This is the logic for checking rows. This is the logic for checking columns. This is the logic for checking diagonals. See how clean this thing is. Now the same thing over here was written in this nasty manner. Do you see that there is hell lot of difference between this code and This code, how many of you can realize that there is truly a lot of difference? And do you see, if let's say you were working in a gaming industry and people before you had written this kind of code, it would have taken you a lot of time to understand what it's doing. But if the code would have been structured like this, it would be a piece of cake for you to understand what it's doing, right? So clean code is valuable because it increases your learning rate of what the code does. Now, when you write a clean code, you can see here, this code was also doing exact same thing. But here everything was dumped inside. You see the variable names, array. It's nonsense. Array could be anything, right? But here, if you take a look, this board made your life very easy. So one thing that helps with clean coding is self-explanatory names. The variable names, function names, everything should be such that it should be self-explanatory. You should not have to put lines of comment. See, it is said that if there is a piece of code which requires some line of comment to be added, checks if game is up, then that code smells. It's bad. Something is wrong. So you have to write English to make people understand. But do you believe that this code, does it require any line of documentation? Do I really need to put what it does? No, because in itself it feels like a prose or poetry. I mean, it feels like it conveys the idea what it's doing. So no comment is needed. So a really clean code, a truly clean code is that which does not require any documentation, does not require any comments and all that. Okay. And yeah, naming conventions have to be self-explanatory. And now when you do that, you break your code into small, small parts. So you write another class called as board. So this is your board. And this board internally contains a 2D array. So this 2D array is completely hidden from the code that you have written here. In this piece of code, we are nowhere dealing with that 2D array. And here, that entire logic of dealing with 2D array was scrambled and, dirtied over here, right? So this is how you hide the internal details and show only the things that are useful, that are important. Okay. So yeah, now you can see, like, if you have read the code, you would totally understand like uh, what it does and what were the key benefits over here. But do you see that one real game changer in clean coding is naming technique, self-explanatory naming convention? How many of you feel that just because we had put right names, it became very easy for you to understand what the code is doing, right? So that's a big thing. Now, there are few important things to take care of while writing any clean code. In fact, there are too many, but I would try to touch upon few basic things. See, um, so I'll ask you a question. Let us say you have to write a method, a random method. I'm just writing it here for now. So that method should basically check uh, if a node is right child of the other node. So let's say there is a binary tree and you have been given two nodes of the binary tree and you have to check if one node is the right child of other node or not. Okay. So one way is that you would write a code like this: public boolean is the right child. And here you would pass the two parameters, node n1, node n2. Okay. Tell me, what is not so good about it? Here, the naming convention is all right. Naming convention makes absolute sense that we are trying to check whether a node is right child of the other node. But still, there is something about this function which I am not able to digest. Yeah, n1 and n2. Such kind of ordinal naming conventions, such kind of ordinal naming conventions should be avoided at all costs. These are next level nonsense. See, when we are in college, we have this habit of declaring variables like this. I1, I2, J1, J2. Have you done that? Tell me honestly. Have you done this thing? Yeah, we have this habit, and we carry this habit when we go to industries, right? And if we make such mistakes in company interviews where interviewer might be very interested in clean coding technique, they would not be happy about it. So because they create confusion, and more than confusion, frustration, because somebody who is this code, now let's say it contain here the logic is quite thin, but let's say for some reason the logic happens to be very heavy, the person will not be understand that, hey, in the first parameter should I pass parent, or in the second parameter should I pass parent. But if somebody wrote it like parent child, then it makes a lot of sense. Then somebody who is looking at this function can clearly understand that, hey, the first argument should be parent and second argument should be child. Then only this code will be able to work correctly. And then the logic would also make much more sense that, hey, if parent right pointer is equals to child, if parent dot right is equals to child, return true, otherwise return false, right? So this is another important thing with regards to naming convention. Okay. Um, all right. This makes sense. Do you understand this thing? So from today onwards, whenever you are writing a code and doing this thing, just ask yourself, can you not do something better? Can you not give some better name around it? If you can, stick to it. Okay. Um, Another thing, have you seen a function like this? Public int max, which probably takes two integers, a and b, and returns their maximum. Have you seen this function? This function is present in Java, C++, almost all the languages, which takes two numbers and returns the maximum. Okay. Should this also be followed for loop control variables? Yes. I mean, in organizations, when you loop over something, you do not do I equals to 0. No. You use proper name for it, proper loop control variable for it. Okay, so this function you have seen, which takes two integers and returns their maximum. But have you seen this function, which probably takes three integers or maybe four integers, right? Okay, if you read any good piece of code, which a matured software engineer has written, or any good library, you would see that a function contains lesser than three variables. A function contains lesser than three variables. By variables, I mean three arguments. Why is that so? Why is that so? The reason behind that is, if you increase the number of arguments that you are passing, then whoever is using that function will have to kind of remember that, hey, the first argument is user, the second argument is password, the third argument is maybe user 2, this is password 2. So he will have to remember the order. And as the value of n increases, the number of orderings increases exponentially or more than that. See, what is the, if let's say there are n items, how many orderings can be there? If you have n items, there can be n factorial different orderings, right? So if the value of n is 1, there is only one order, 1 factorial. If the value of n is 2, 2 factorial, which is 2, but 2 is still all right. It's easy to remember. The moment it becomes 3, it becomes 3 factorial, which is 6. The moment it becomes 4, it becomes 4 factorial, which is 24. Very hard, very confusing. So this is followed as a rule of thumb that try to write functions which contains fewer than 3 variables. And now this reason, if you relate to it, you would understand that, yeah, I mean, that is a very, very strong reason, right? Okay, ternary operators and all can be avoided. I mean, see, at times when you have written some piece of code and it's already clean and, somewhere ternary operator is something which a lot of people use, okay? And if it's a very simple ternary expression, if it's not compound one, then that's okay. But if it's compound, maybe ternary inside ternary, then ternary inside ternary, that should be gotten rid of because that is pretty hard to understand. Okay. Why the number of variables should be lesser than three? Because it's pretty hard to remember their ordering if there are three or more. Okay. Uh, cool. Another thing, see, if I write a piece of code, maybe something like this, where I say, let's say there is a public string analyze marks. So here, let's say you pass marks obtained by a student, and then you put some logic. You put logic like if marks lesser than 25, return failed. And then you say if marks lesser than 50, then you do something. If lesser than something else, then you do something. This is kind of very confusing. Using such numbers, they are called as magic numbers. Why they are called as magic numbers is because somebody who is reading this code for the first time, it will be very hard for him to understand. So let's say for lesser than 50, you are returning that is factory. For that person, it will be very hard to understand that, hey, what is the significance of this thing? And like, what do you really mean by this? I mean, is this 25? Is it out of 100 or is it out of 200? What is it out of? Or is it in percentage? What exactly it is out of? Some people, what they do is they say that, I mean, not say, when they write the code, they say that if a particular integer is lesser than 1050 or 1090 or something like that, we will do one thing, otherwise we will do the other thing. Such kind of magic numbers should be avoided at all cost. Instead of magic numbers, what you should do is you should probably go here and define a clean and clear variable. So you can have an integer variable. You can say this is your threshold. Threshold equals to 70. And now in your functions, you can put checks that if marks is lesser than threshold, then do this thing or that thing. Now that word threshold makes a lot of sense for somebody who is reading it, that okay, that's the threshold for failing or that's the threshold for passing. But using such magic numbers is, very, very confusing. Somebody who doesn't know what this number means, he will. And also one more thing, that if let's say there is a particular number that you want to use at multiple places in your code. Now the moment you have to change it, you will have to change it everywhere, right? So let's say threshold is 70. You'd have hard coded, it is called as hard coding. You'd have hard coded that 70 here, everywhere else. A better idea is to use a variable, and if you want to change the value, just change here, it will be reflected everywhere else. So another important principle is to avoid hard coding at all costs, right? So these were some very, very basic clean coding principles. Um, do they make sense? Do you understand? So all of these things have to do with enhancing readability, which is the first aspect of clean coding. What about global variable? Global variables, there are pros and cons. Okay. Okay, first let me talk about the second part that I really want to speak of, because I want to give it a logical conclusion. So yeah, what was the first part? Readability. We should have enhanced readability. The second thing is extensibility. What is the meaning of extensibility? Any ideas around it? Somebody says write clean code for extensibility reasons. Why? It allows a lot of plug and play. It allows a lot of plug and play with the code without modifying it a lot. And this is incredibly important. And this is the harder thing to learn, the harder thing to do. Okay. So I'll take a very simple example, and based on that, probably you will get. So let's say I just have piece of code here, and here I have an array. Okay. This array contains some numbers like 3, 2, 9, 8, 10, 7, 6. Okay. And now, let's say I want to introduce a logic, and through that logic, I want to filter even numbers. When I say filter even numbers, What I mean is that whatever your array is, from that array, I want to just collect the even numbers and throw everything else out. Okay. So you would say that, hey, it's very easy. Just write another function, public static, which returns an array, another array. You can call it filter. And here you can pass your input array, and you can just put your entire logic here. You can say int b, right, arr dot length. And then you can have a logic to just collect the even numbers from this. You can say for int I equals to 0, I smaller than arr dot length, I plus plus. And you would say that, yeah, if arr of I mod 2 is 0, you would do b of, let's say you have a count, c equals to 0. You would say b of c plus plus, sorry, b of c, let's do that, c plus plus outside, b of c equals to arr of I, and you will do c plus plus, and then you can return b. Right now, this filter method works well. If you call this filter method for this array, you will get another array which is created from the same array, but it has extracted only the even numbers from here. So you can say int filtered array equals to filter of arr. And I hope it will work well for you. Now, let's say over the time, requirements evolve. So this requirement comes that, hey, we want to be able to filter even numbers, and at times we want to filter odd numbers. At times we want to filter some other sort of numbers. So maybe prime numbers. So what is the way to achieve that? So one way to achieve that is, I mean, if people want different behaviors, they end up writing different functions. See, behavior is just like algorithm. Filtering even number is a different algorithm. Filtering odd number will be a different algorithm where you will have to put not equals to condition. Filtering prime number will be a very different algorithm. So if you need different algorithms, you write different functions. This is what people do, right? And sometimes people say that, hey, let's do one simple thing. Let's just pass a flag here, int flag. And they say that if the flag is 0, let's run this logic and extract even numbers. If the flag is 1, let's run the logic to get odd numbers. And if the flag is 2, let's run the logic to get prime numbers. So they put a lot of if checks inside this function, and it works well. It works perfectly well. And then, yeah, switch cases or if else conditions, whatever. But do you see there will be a lot of conditions? If you stick with this design, you will say, hey, I just have one function and it's pretty cool. But my dear friend, it's not cool because this function is very hot. It contains too much of code inside it and too many if else conditions inside it. So if tomorrow, let's say somebody says, I want to be able to filter the multiples of 5, you will have to put another if check, another switch case to accommodate that. So this function is going to be a very fragile function. You will say that, hey, it's great, you just pass the flag. And how nasty this flag is. I mean, every time something comes up, your flag, the varieties of flag can increase. And somebody has to remember that, hey, 0 is for even numbers, 1 is for odd number. Although you might feel that this code is a better code, but this is as bad as writing separate functions could have been. In fact, worse than that. So do you understand this point? That this is not the right code. So what is the pain that we are feeling here? The pain that we are feeling here is, here we have just passed a signal. That signal is in the form of flag. And then from that signal or flag, we are guessing the algorithm. We are guessing the algorithm. So if the flag is 0, we know that this should be the algorithm. If the flag is 1, we know that the algorithm should be for odd number. And if it's 2, it should be for prime number. Can we not pass the algorithm itself? Now, this is a This is the, with respect to low level design or clean coding, this is the revolutionary thought that we are just used to pass the data. Whenever we write a function, what do we pass? We pass integers, string, arrays. They are data. We are just used to passing data. Can we pass algorithm? If we can pass algorithm, it will be great. But okay, how many of you are able to understand what I'm trying to say? Maybe you are able to understand, but you are overwhelmed by the fact that algorithm कैसे pass करेंगे? How will we pass algorithm? How many of you are overwhelmed by this fact? Yeah. Okay. So there comes the magic. There comes the right thing. And let me tell you, all of you must have passed algorithm somewhere wherever you have used sorting of an array. When you sort an array or vector, you pass one thing called as comparator. Do you know about this thing, comparator? What is this comparator? It is a data? Is it some data? No. What is it? It is a logic. It is a function. It is an algorithm which contains the logic or algorithm for determining which element to come first, which element to come last. Yeah, interface and all, they are just constructs. But what I'm trying to say is that this is the algorithm. So if you are writing a code which allows somebody to pass algorithm instead of passing the data, then things become very, very easy. And now you will understand. So now just hold on with me for some moment. You will understand it. So in different languages, there are different constructs. Like, see, in Java, there is something called as interface. In um, in C++ and Java both, there is something called as abstract class. So basically, the idea is what the idea is that you create something which can have multiple forms. You might have heard about polymorphism, but I'm not touching polymorphism for now. You create something which can have multiple forms. So if you want to create something which can have multiple forms, what you do is you create an interface. So I'm just creating a simple interface and I'm going to call it filter. Okay. So there is an interface called as filter. And what this interface does is, uh, now what I really want is that people should be able to create different forms of filter. People should be able to create different forms of filter. So even number filter, odd number filter, prime number filter, and all sorts of filters, right? Maybe multiple of five filter, all sorts of things. So I would say let it contain some function, and those functions should be implemented later on within those classes which will implement this interface. So somebody can say that, hey, let's say the first method it can have is filter. What it will do is it will take a list of integers, nums, okay? And what it will do is it will return another list. So that is filtered list. That is the filtered list. And maybe it can have one more method, Boolean. Okay, if you watch the code till the end, then you'll be able to understand. It's not like you just understand. It's a little different here in clean coding and low level design. You will not be understanding 10% after 10% code is over, 20% after 20% code is over, 50% after 50. No, if you have watched everything, then all of a sudden it will strike. So here the game is different. You'll have to watch till the end. Okay. I mean, so you'll have to have a lot of patience. So let's say this is one function, and then there is one more function, Boolean accept. In this function, let's say you pass an integer, uh, and then it says whether that number is accepted in this filter or not. And now, as I told you, it can have multiple forms. How do you allow interface to have multiple forms? You write different classes which implement this interface. Now, if there is a class which implements an interface, that class has to implement these functions inside it. So by that, what I mean is, if I, let's say, write a class, even filter, and I say, see, you might not know Java, you might not know interface, but no worries. As much I am saying, if you're able to follow that much, you will be able to get the gist, the idea. Okay. So if this class implements filter, it'll have to implement the methods which are declared in the filter. And now you can implement those methods. So you can write the code. You can just say that, hey, I'll go ahead and create list answer equals to new of array list. Okay. And I'll return this. And here I'll have that logic. I'll say that if for integer num inside nums, and I would say if accept num, then we are going to push this inside the answer. So we are going to say answer dot add num. And then finally we will return this answer. And here we can have a logic that we will accept only if num mod 2 is equals to 0. Okay, just read this code this much and tell me if it is making sense what it is doing. So what are we doing? We are just taking a list and we are iterating on all the elements of this list, and we are calling this accept method to check if it is even or not. If it is even, then only we are adding it to our answer, and finally we are returning our answer. So do you understand what this code is doing, right? Okay, so this is one kind of filter, which is even filter. Now you could have written some other kind of filter. You could have written odd filter, and you would say this odd filter again implements filter interface, and so it'll have to implement these methods. So what I'll do is, I mean, a lot of code between even and odd are similar, so I can do copy paste in this case. But if you talk about cases like prime or multiple of 5 or something else, then it could be very, very different, right? So here you can say, in case of odd filter, I have this liberty of doing this. Here, what will change? Just this thing will change. Here, I would say if num mod 2 is not equals to 0, then do this. So see, do you see like what we are doing here? We are just filtering the odd numbers in this case. Now, what I'm trying to say is that if I come back to my this particular class here, okay, I have used list there, so I forget I was using arrays here. So let me just declare list. And now if I sort of create a list of integers, nums, and then I say this is arrays as list 2, 3, 9, 11, 0, 4, 6, something like this. Now I can just say that, hey, uh, if I have a method called as filter like this, okay? And now uh, it would return a list of integer, and here I would pass a list. And here, as I told you, I don't want to pass data, I want to pass algorithm. What is my algorithm? My algorithm is filter. Filter the interface. Okay, filter the interface. Now we all know that the two classes that we wrote, they are nothing but implementations of filter. So what it means is that somebody can pass a filter as even filter, and somebody can also pass a filter as odd filter. It would just work well. Okay. And now all that I'll have to do over here is I would say return filter dot filter nums. That's it. So what I'm trying to tell you here is, let's give it a different name. There are a lot of filter nums. Okay. So I can call this function filter nums, and I can pass here my numbers, and I can just pass an instance of even filter. If I do this, I will end up getting some result. Just to gain some confidence, let's print this for integer I in, not a great naming convention, but I'm doing it quite quickly. So yeah, system dot out dot print I, yes, yes. Okay, let's run this code, see what happens. Okay, you can see it ran and it printed 2046, which makes sense because it filtered 2, 0, 4, and 6 for me, which are the even numbers. If instead of even filter, I pass the odd filter, then in that case, it would filter out the odd elements for me. And that is exactly what has happened. So do you see that here we are passing something which is of type filter, because the method that you are calling is inviting that, hey, give me a filter, give me a filter. Now you are passing, see, if a method takes an integer, that integer can be of different type, 1, -1, 0, 3, 4, 5, anything. Here you are taking a filter and this filter can be of different types. The filter can be an even filter, the filter can be an odd filter. So you are literally passing an algorithm and it would work on top of algorithm and get the job done for you. But now won't we have to remember the name of filters? That's all right. That's all right. You can have multiple forms of something. I mean, somewhere you have to uh, know that, okay, this filter, and it's pretty intuitive, isn't it? Somebody who is checking out your code base, if he stumbles upon a file like this, he would be able to understand that, okay, this is even filtered. This is required for the purpose of filtering out even numbers. And this is required for the purpose of filtering out odd numbers, right? And now the benefit that you have is that in future, if somebody has to create a new filter, he can do so independently without disturbing the code which is written over here. So let's say somebody has to write a prime filter. He would say, let it implement this filter interface. And now he can write whatever logic he wants over here without disturbing the logic which is present inside odd filter, without disturbing the logic which is present inside even filter. So they are all independent of one another. Previously, what was happening? You just had one method, and in that one method itself, you were dumping everything inside it, right? And here you have separation of concerns. There are different filters which are dealing with different stuffs. The great thing about it is that if you look at this method, this particular method, this particular method now no longer has to contain those if-else conditions. In fact, those if-else conditions are nowhere present in my code base now. If-else conditions that, hey, if the flag is this, do this. If the flag is this, do that. If the flag is this, do this. No. Such kind of if-else condition is nowhere, conditional logic branching, nowhere it is present. Because whatever algorithm is sent, we invoke that algorithm and it works. So we just call the filter method, and what you passed was an odd filter. The filter method of odd filter would be invoked. And if you pass an even filter, then the filter method of even filter would be invoked. So all those things are kind of gone. So this is one huge benefit. So when you learn about things like polymorphism, multiple forms, this is the idea. It's what is the core idea? The core idea is to allow a user to pass multiple forms of something which could have different algorithms in it, not just different data. As of now, when you were writing functions, you were just passing different data. Like if you pass integer, you can pass integer as 1 or 100 or 200 or whatever. But if if you have, let's say, a use case where you have to pass different algorithms, different modes of working, then in that case, you will have to do something like this. Okay. There is one huge benefit of it on top of it. Yeah, one of you is asking, this is for strongly typed languages. Yeah, of course. When you design backend systems for scalable architectures, even just go back and look at how many organizations still use languages like Java or C++, you'll find there's still a plenty. If you're just trying to test a product, building an MVP or something like that, you can build it in JavaScript or any loosely typed language. But if you are designing for an organization where there are thousands of people who are working, cross team collaborations, today you are working on this code, tomorrow you might go out of the team, somebody else might come. then these things play immense role, huge role. So that is where, so you would see a lot of people who probably initially work for startups, they are not able to appreciate these things because they are not exposed to such sort of code base. But people who, let's say, passed from the college, got into maybe Google or Amazon or Microsoft right from their day one, they understand the value of it. So I'm not saying that that experience is not important, that the startup experience has its own benefit, this has its own benefit. So you need to take best of both the worlds. That's the idea. Okay. Now with this thing, one more thing has become very, very, see, I'll show you one super interesting thing. Um, let's say somebody wants to filter based on some and condition or condition. So what I mean by that is, somebody could say that, hey, I want to filter if a number is even. So if a number is even, or the number is multiple of 5. If any of these conditions is true, I want to filter those numbers. So you can take an example. Let's say if this was the case, which numbers you would have extracted? You would have extracted 2, 0, 4, 6, and 15 also, right? Because 15, although it is not even, uh, sorry, not and or. So if you have an or condition like this, you'd want to say, you understand what I mean by or conditions. I want to basically extract numbers which falls in this category or that category. It is very easy to create a generic filter like that. You can just say that, hey, um, let me just write a method, call it or filter. See how interesting it is. It implements filter and it has these two methods. Now here you can say, pass me the two filters with which you want to take or. Okay, so private first and second. So you can take these two things in constructor. You can take these two arguments inside your constructor. And then here you can say that, hey, let me create this result list, new array list. And then what I can say is for integer and inside nums, if first dot accept n or second dot accept n. If either of these conditions are true, we are going to do result dot add n. And then finally, we will return this result. Okay, read this code and tell me how many of you are understanding what it is doing. So imagine somebody created this filter and in the constructor of it passed the first filter as even filter and second filter as prime filter. Now this is an OR based filter. So if a number inside this is even, we want to have it. And if it is prime, then also we want to have it. So imagine that your input was something like this. You had 4, 7, 9, 8. Can you tell me what should be the output if we want to filter all the even and prime numbers? Which numbers should be filtered out of this? So what are the even numbers inside this? 4 and 8. And what is the prime number? 7. This code will exactly do that thing because the first thing that you have passed is an even number filter and the second number thing that you have passed is a prime number filter. And now what we are doing is you are iterating on this array, and if a number is accepted by first filter or it is accepted by second filter, there is an or condition. In that case, you are pushing that in your result and finally you are returning the result. So what it literally means is that somebody can create an OR filter, pass both the kinds of filter inside it, and it'll work like a charm for that person. So I can just write the constructor for you, public OR filter. and takes filter, first filter and filter and filter. And here you can say first equals to first filter and second equals to second filter. Okay. Now if I go to my main and let's say I want to do something for my fun exercise. I want to do new of or filter. And we all know that or filter, its constructor wants two things, filter 1 and filter 2. What will happen if I pass the filter 1 as even filter and then I pass the filter 2 as odd filter? Can you tell me what will happen? What will be the output which will be printed in this case? All the numbers. All the numbers, right? Because how will this OR filter behave? It will check. See, you now understand, right? How will it behave? It will check whether a number is accepted by first filter or not, whether it is accepted by second filter or not. If one filter is odd and the second is even, it will either be accepted here or here. So in reality, if I try to run this piece of code, if I have done everything correct, then the output should be this entire array, all of this array. Yeah, so you can see everything has been printed, right? So this is how OR filter has behaved. Now, if you want, you can create another filter, which could be AND filter, right? So you can say that, hey, let me go ahead and write another filter called as AND filter. Now this has AND based logic, right? So this also implements the filter interface. And here the logic will be pretty similar, in fact, almost similar. But the only difference will be that instead of OR condition, you will get a AND condition. So if you come here, you dump this code, here you will have AND condition, right? And now, yeah, so from this OR filter, you can copy this part also. Just copy and paste it here. Now tell me one thing. Yeah, it is AND, not OR, AND. Now happy? Yeah. So now you can come back to this. If I create AND filter, can you tell me what will be the output? What will the output be now? Nothing. Why nothing? Because there is no number which is even also and odd also. Now see how amazing it is. Because in the AND filter or filter, you can pass anything. Let's say you have created another specialized filter called as multiple filter. So in multiple filter, what you do is you say that this implements filter, and here what you do is you pass an integer k and a multiple filter. So here what you basically do is you only filter those numbers that are multiples of k. Okay, so let me just copy this code and put it here in the multiple filter. Oh, sorry. Where did I put it? Yeah, I need to put it here. So here in the accept method, what I'll do is that if a number is a multiple of k, so if num mod k is equal to 0, then only I'm going to accept it. Otherwise, I'm not going to accept it. Now I can say that, hey, let me just go back to the main function. And let's say I create AND filter of an even filter and multiple filter of 7. Let's say 7. Okay. Okay. Who will tell me if I run this array, if I run my code on this array, what will happen? So you are saying that you want to filter on the basis of AND condition. And what is your AND condition? That the number should be even and the number should be a multiple of 7. Only if the number is even and multiple of 7 that I wanted, then I wanted. So you would only want 14 and 28. Now, if I run this piece of code, 0 is also a multiple of 7. Okay, does it feel amazing? How many of you feel this is just amazing way of writing code? You might not have been able to connect the dots at the beginning, but now when you are reading it, you must be able to connect a lot, isn't it? That what's truly happening over here. Okay, if filter method is containing the same for loop again and again, so why we are not writing at one place? You can't because it's not necessary that, okay, they're not the same for loop. I want to tell you that. See, multiple filter, here the logic is different. Here, this logic is different, right? And that logic for the odd numbers, they're different. Somewhere else it could be different. Like let's say you look at the AND filter. Here again, this logic is different. You're taking and. If you feel there is some common part of code, it can be moved to a common parent. So you can use the idea of inheritance over there. So if you feel maybe you could have put this code in a common parent and then only these conditions here. If that is what you're thinking, yeah, that can be done. So you can save upon some code redundancy through it. That is one part of it. But do you see the main benefit? How immense extensibility you are gaining. You are gaining immense extensibility. So if you look at what you have done, you have written your own query language. I'm not sure how many of you realized it, but let me help you realize. You wrote your own query language where somebody can put compound logical statements. Let me help you understand what I mean by that. Somebody says that I want to filter those numbers which are either a multiple of 5 and multiple of 3. They should be multiple of 5 as well as multiple of 3 or even. It could have been prime also, but I have not implemented a prime filter because it will take some time. But I can do it. Only the accept method needs to change, right? So if I have to create something like this, I can do it pretty easily. Can I do it? Can I do it? How can I do it? I would say what I need at the end of the day is an OR filter. Okay. So keep looking very carefully. I need an OR filter. Now the first argument of this OR filter should be this, and the second argument should be that. So let's first write the second argument. The second argument is even filter. So new of even filter. The first argument is AND filter of two things. The first argument is AND filter of two things. So I will create a new of AND filter and make it contain two things, where the first thing is multiple of 5. So it would say new of multiple filter pass 5, and the second thing is new of multiple filter, here I'll pass 7. See, this entire thing that you have created, this entire thing that you have created, it is a filter only. It is just a filter which you are passing here because this thing is accepting filter, but it has a compound form. It is a very complicated thing. It is a very compound form and it will work well for you. So let's just take an example. Um, let's say you have this as your input. Can you tell me which numbers should be filtered if this is my condition? That I either want even numbers or I want something to be a multiple of 5 and 3. So for sure, you will get all the even numbers, which are 2, 0, 14, 6 and all. But apart from that, what are the numbers which are multiple of 5 as well as 3? Yeah, 15, 30 and 45, right? So you will get all the even numbers. And apart from that, you will also get 50. 30 you will get because 30 is even only. But 15 and 45 you will get because of this condition. Will you get 3? No, because 3 neither follows this group nor follows that group. 3 is a multiple of 3, but it is not a multiple of 5. Okay, so let's run this piece of code, see what happens. 2, 0, 14, 6, 28, 30. 2014. Did we miss on something? 2014, 628, 30. We missed out on 45. Why did we miss out on 45? Very weird. Oh, because I passed 5 here and I passed 7 here. I don't know why I passed 7 here. It should be 3, right? Yeah, so let's write again. Okay, it looks like maybe I have maybe muddled up somewhere. I must have muddled up somewhere. That is the reason it's not behaving the way we want. We can debug and find that out. But the basic idea is that you are able to create a filter of your choice, even if it requires some compound logic behind it, right? It works just perfectly well. It works kind of magically well for you, right? So, I mean, that's the idea. If extensibility was not a prime reason, then people would not be clean coding a lot. They would not be following design principles. But then this example, I believe, must have given you a lot of idea around what true extensibility is and why that is important, right? Uh, so yeah, if you want a new filter logic, let's say you want to filter out prime numbers, which I have not done right now, you will have to write a new class for it. But see how extensible and pluggable they are. When I say pluggable, this is exactly what pluggability means. Inside an OR filter, you can plug multiple filters and create an AND filter on top of it. So filter of filters and all, and then it just works. It just works like a charm for you. So that's the basic idea over here.